Alright, so I'm going to go over some of the homework from Friday. It's on page 590, number 58. So basically the first question, 58, is asking that a test charge experiences a force of 0.3 newtons. So we know that there's a force of 0.3 newtons and it's placed in the electric field. So the electric field is E, and that's 4.5 times 10 to the power of 5 newtons per coulomb. So if you anytime you see that, you know that's your electric field. Question's asking you what's the magnitude of the charge. So that's your Q. We know that we have the equation. This one is very straightforward because it's just using the E is equal to F over Q equation. So you can see that your newtons from your electric field is from your force, and charge is from the Q. Substitute all this stuff in. So this one we're trying to find Q, that's what we have to isolate. So if we were to plug all these numbers in, you would get 4.5 times 10 to the 5 is equal to 0.3 divided by Q. Isolate Q by cross multiplying, so that has an invisible 1. 4.5 times 10 to the 5 Q is equal to 0.3. Divide both sides by this. And then your final answer, if you cancel those out, Q is equal to 6.7 times 10 to the negative 7 coulombs. So that is your answer for 58. So if you want to move on to 59, 59 is asking you what is the electric field. Let me align this. Electric field strength 20 centimeters. So we know that the D or the R in our equation is 20.0 centimeters, and this centimeter should immediately tell you that you need to change that into meters. So I just do it automatically. Centimeters is 100 centimeters is for 1 meter. So basically you just have to move the decimal 2 times to the left to get 0.2 meters. This is from a point charge, so your Q is 8.0 times 10 to negative 7 coulombs, and you're trying to find the electric field strength. So you can notice that in this one you have a distance, you have a charge, you have to find the electric field strength. So you can't really use this formula. You can, but you have to add something to it. So if you remember from the notes that there is another Coulomb's law that we talked about, and that is also equal to force is equal to KQQ over R squared. I don't know if I'm on the screen or not. Let me double check. Oh, I am. And basically what it is that you're just rearranging this formula. So if we were to take this, E is basically is equal to force. This is force is in numerator. And since Q is in the denominator, it's also the same as multiplying by 1 over Q. Because if you multiply F times 1, that's just F. And then Q multiplied by that invisible one is just Q at the bottom, which gives you F over Q. So then we can substitute this Coulomb's law into F, giving you KQQ over R squared times 1 over Q. You're going to notice that there are two Q's here. One is for like QA, the other one is QB for 2-point charges. So the Q will cancel one of them. It's either one of them, which gives you a final equation of, let me move this up a little bit, KQ over R squared. Okay, and the R is basically the distance that we have from here. I think we're still on the screen. And now, once you have this is your new formula that you can use to find the electric field of a point charge separated by a distance. So I'm just going to move it over here. E is equal to K. K is your constant. So it's always 9.0 times 10 to the 9. If you're wondering about the units, it's newtons meters squared over coulomb squared. And then your Q is going to be that point charge of 8.0 times 10 to negative 7 coulombs. You're going to divide all this by your distance. Now that it's changed in meters, it's 0.2. Don't forget the square. and then plug all this stuff in, and your final answer should be 1.8 times 10 to the power 5 Newton coulombs. So all these units will cancel except for newtons and coulombs. Alright? So then that's your final answer for number 59. I think we're still on screen. Okay, so if you go to next question is number 60. I'm just gonna go to the next page. And at the top, let me fix this alignment. Number 60. Number 60 is basically you have this charge and it experiences a force of 0.3 newtons, and this is your charge in the diagram. So you're given a positive point charge, so point charge is your Q, 1.0 times 10 to negative 5 coulombs, and experiences a force of 0.3 newtons. You're asked for the electric field. Okay, so basically it's all given to you. You can see that you have your Q, you have your E, and you have your electric field. So you're going to use this formula, plug these numbers in, and then you're going to get a final answer of 3.0 times 10 to 4 Newton coulombs. So that is your answer. Okay, so number 61 is 3 parts. Number 61 is asking the electric field in the atmosphere is about 150 NC. So basically that is telling you that the electric field is 150 Newton coulombs. First part of the question A is asking what is the direction. So remember that if it's a negative charge, this field is downwards. If it's negative, it's always going to go opposite from your field. So if it's opposite, then it's going to go upwards. Okay, because negative charge. If it's a positive, then it will go towards the, or not towards, it will go with the electric field because it will just repel. Part B, find the electric force on an electron with a charge of negative 1.602 times 10 to negative 19. That's basically the charge of your electron. You're just plugging this number in again into this equation. So to find your electric field, or you're not finding the field, you're finding the force here. You have the electric field, so it's 150 is equal to, the force is what we're trying to find, and your charge is negative 1.602. I'm just going to squish that in to get that. Cross multiply, force is going to be 150 times negative 1.02602 times 10 to negative 19. That's a lot of numbers. And finally you'll get the number 2.4 times 10 to negative 17 newtons. So since this is going to be positive, I think, let me double check this. This is number 61. Yeah, it's going to go upwards. So this is going to go up. Okay? Because your final answer is going to be negative. So it's going to go up. I don't know if you can see the negative sign here. And that's for B. Okay, so at any point if you need to relook at this, just go and stop the video and just go back up and copy it down. For part C, this is now you comparing this force of part B, so the electric force to the force of gravity. So in order to get that, you have to use, remember, electric field formula basically is similar to your force of gravity, which is mg. This electric field is basically measuring your gravity. Okay, so for electric field, it's force per charge. For gravity, if you rearrange this, it's actually force per mass. Okay, so we don't really need to rearrange this because we need to compare the force. So this is what we want. We need to use this formula. I'm just gonna separate all this, move this up a little. And the mass that we have right now is 9.1 times 10 to the negative 31 kilograms. And then for the force of gravity, you might be wondering, well, what are the units, or how do I use this? Gravity, remember, affects all masses equally, so it doesn't matter if it's kilograms or grams. You can use kilograms and it's still 9.8 meters per second. If you don't believe me, if you just want to calculate the force, we can say for 1 kilogram it still has 9.8 meters per second squared. So when you multiply this is still 9.8 newtons per kilogram. Okay, that's basically what it is. So you can just plug this number in, this 9.8 newtons per kilogram. If you multiply this out, you should get an answer of 8.9 times 10 to the minus 30 newtons. Okay, and you can, if you compare this to that, that's a lot smaller than the force of the electric force. Okay, so that's number 61, and I'll stop it here and do the second video for the last 3 questions. So good stuff.